This video will be an introduction to substitution reactions. We have two main substitution reactions, SN2 and SN1. For SN2, we're going to have methyl primary and secondary alkyl halides. For SN1, we're going to have tertiary, allylic, benzylic, and alkyl halides. 2 is a concerted process where everything happens at once in one step. For SN1, there is going to be a slow and a fast step. Typically, the first step is the slow one, because that is when the leaving group comes off first. For SN2, you will get complete inversion for the stereochemistry. That means you will go from R to S or S to R due to the backside attack. For SN1, it will be a racemic mixture, meaning you will get a pair of enantiomers with R and S. Typically, you might get a little bit more product of the inverted rather than the retained configuration. For both SN2 and SN1, a good leaving group is going to be the weakest base, or the strongest acid. For nucleophiles, for SN2, generally a smaller nucleophile is going to be a stronger one. This is because the nucleophile does the backside attack. The less steric hindrance there is, the faster the reaction will occur. And for SN1, usually you have poor nucleophiles. There is no effect on the rate. Now for the solvents of choice, you can have two options. One is called an aprotic polar solvent. For an aprotic solvent, that means that you wouldn't have hydrogen bonded to an oxygen or a nitrogen. There are protic polar solvents where you do have hydrogens bonded to an oxygen or a nitrogen. For an aprotic polar solvent, typically it will determine on how basic the nucleophile is. And for the polar, that will depend on size, or you can think of it as polarizability. Now, if you were doing an SN2 reaction, and if you had to pick between the two solvents, if you have a negatively charged nucleophile, you would want an aprotic solvent. And if you have a neutral nucleophile, you would want a protic solvent. For SN1, typically your stability of the carbocation will determine how fast the reaction occurs, and we want protic polar solvents. So the solvent of choice becomes an important factor when we have reactions that can do both SN2 and SN1. And typically, primary and secondary allylic and benzylic halides will do both SN1 and SN2. We also have vinylic and aryl halides that will not do SN1 or SN2. That concludes the introduction video to substitution reaction.